extra?
So we'll do a little different today. I'm going to give you the solution for the I don't know if you have done it or not. That was an exercise. But for the friend group, it's a question of the end of the first you have to come back to the problem of the optical, then calculate everything with the diopter equation. Okay? So, the opticube was where? The stick was in the middle. Okay. 5 centimeters here. An image here. We saw during the ATP that the image had the same size as the object. Okay, but you could see it bigger because it was closer to the eye. Okay, and so the problem, the exercise was to, the one on the model was to calculate the image on the retina to check that the size is bigger when it's closer. Okay? So you have this diopter. Index of the water inside, index of the air. Okay? 30 centimeters for the problem. And the eye was another diopter with 2 centimeters. Okay? And so I said last time, when you have a problem like this one, you have 2 diopter or 2 lenses, 2 optical systems. Try to choose a notation such as S1 and S2. We could say this is A1, B1, and the image given by S2 is somewhere here, okay, A2, B2. It has to be there. Otherwise, I don't see it. Okay, first question. You had to find S1, A1. I do not do the calculation, but I check the method. What should I do? What should I do to compute this?
We can use the formula.
Formula, diopter formula, with
The 4/3.
1/3 and what? Okay. What is this distance? It's given because the stick is at the center of the cube.
5 centimeters.
And we have, yes, we have 10. It's
5. 1 second. Minus? No,
minus 5.
Oh, because it's the bar.
It's always the bar, always. Okay, minus 5. Minus 5. Yes.
I just have a question. Why is the diopter that way?
Why is the
diopter that way? I don't know how to explain it, but why is it like this and not like this?
The diopter of the eye.
of this?
Yeah.
But the index.
Yeah, but why?
Because the index is.
No, it's not because of the index.
Because of the
It's because it's spherical. We consider that the eye is spherical.
It's just okay. Oh,
to consider a spherical eye.
Okay.
But we haven't seen eyes curved the other way.
Yeah.
Eyes. Actually, I'm not sure about that. Yes, I know, that's eye curve that way. Okay. So, diameter equation gives you value. We check. Okay. And the second question was to talk about the angle. Calculate the apparent angle subtended by the emerged part. Oh, also for the first question, you had to calculate the size of the stick unit, but we have done that already.
Isn't it minus 3.0?
No. Yes. Sorry, it's minus. So we have seen the size, okay? Because this is flat. Of course, we have done that already. That was question 1. Question 2. So I'm reading the question. The one on the Google. Calculate the apparent angle subtended by the emerged part of the stick at the human eye, and the one of the immersed part. Okay? So the question is to compute the angle subtended, this one, the apparent angle for the eye. So you always, start from S2. So the subtended angle for the inner part is this one. For the other one, it's smaller, right? It's that's one. I. Last, inner. Okay. So once you have those values, how do you compute those angles? We are in Gauss approximation. Okay.
What does that mean?
What does that mean?
I have an angle is equal.
That's the value of the angle.
Oh, oh yes, that one over the big one.
No, for not. You have to compute both. Just compute both of them.
Yes.
Okay? So Gauss approximation, those angles are very small. Okay, so in just compute them in radian. And you get MB over on your first one and the other one.
Sorry?
Brilliant. So we see that this one is bigger. This angle is bigger. Okay. So what does do this optical system actually? It magnifies the angle. It is a magnifier for the angle. Okay, not for the size. Remember, the magnification is 1, but there is an angle magnification, which is not 1, which is different from 1. And we distinguish the two of them. Okay, the magnification, which is a transverse magnification, is different from the angle magnification. En français, on dit le grossissement. Okay. Okay, the third question was to find so what should be SC so that the image of the image part locates on the retina. Of course, SC, well, that's in such a way that the retina is the F, okay? So this is easy, we already know that it's fixed. And then we pass together that the length remains the same, okay? So the focal point is at the same distance. And then what is asking? You have to compute the size of the image, okay? When you have the water and when you have no water. Actually. So that means you have to compute the size to the second diopter of AB and A1B1.
Isn't it A1, B1 for the inverse?
What?
Ah, that's the same. Yeah. Ah, okay, okay.
Non, t'as raison. Non, first. No.
Yeah, but it is equal to AB. So it is AB.
They are the same, yes.
Oui, c'est les mêmes.
What is the distance? Minus 3. But there's no SC. So how do you?
What is SC for this one?
Yeah, what is it?
For this one, where is the center of this spherical diopter? The center is at infinity. SC equal to infinity. 1 over SC equal 0.
Why is it infinity?
Okay?
Why is it infinity? What is that? Oh, it's a circle of radius.
Lower one.
C'est un cercle de
Okay, that's the upper one.
radius.
Yeah, that means that increase the maximum height. Increase the maximum height.
Yeah, that works. Thank you.
Oh, that's
Não,
us.
hier sind too much That's not actually.
So,
Yeah, so 2 years.
what should I use to compute the size? I should
No,
use
that's wrong calculation.
the magnification. I think we
You
M.
want to do something?
Inverse. So I had many questions about it. The transverse magnification, that's the size over the size, okay? Size of the image size. Okay. Okay. So you use the relation and you got. So this is on the document. Okay. And just plugging the number using the same relation. Give you the result. Please do it.
I'm not sure.
And so the magnification is N air over N water. S2A2 over N. Okay. This is
I only want to see that.
with for AB, okay? So AB. The other one, you can do the same thing for one, same relation. Try to do the numerical application of that. Have you done the numerical application of this? Micrometer. It's precisely if no mistake. Hopefully not. Okay. You have another exercise to do during the break. And I will give you a solution, but it's on your own.
Could you explain why A2B2 is equal to that?
Why A2B2 is?
That is equal to what you wrote on the board.
I'm using the expression for the magnification of a diopter. Plugging the notation for this situation, same thing. Okay, second index over first index times image over object.
But where does the ratio of indexes come from?
The ratio of the index?
Yes. Where does it come from?
You mean the relation? Where does it come from?
Yes.
The document I gave to you with those formula. You have the formula for the magnification and the formula of the diopter. The diopter formula and the magnification formula. Just an application of the formula. You need to know them.
But do we know the size of AB and S2?
So I haven't make sure. So this is correct. Is it negative? Yes, it is negative, right?
But we know.
I know it is negative. I know the image is reversed. I know that.
For the transit S2A1.
So for the first one, the first expression, it is not in water. I want to compare the size of that stick when there is no water in the tube to the one when the situation when we have water.
Okay.
So here it's, oh yes, what is what happened? I still have L water because I have this diopter with water, the eye, but no water here. Okay, and I'm using the first calculation. So here for the second one, I'm using A1, B1. The image. You could, replace this by another calculation with water.
But I don't think you got my question. But how do we know AB?
What do you know? What do you mean? It's given. 1 centimeter.
Ouais, mais on nous donne C'est ouais, c'est genre l'épaisseur du stylo.
Non, c'est diamètre. Là, c'est.
Oui, mais le stylo il est comme ça, donc nous on
Ouais.
aurait besoin de la longueur, pas du truc.
I agree. Okay, I understand. That is AB.
Okay, so
1 centimeter is AB.
the one on top is when there is no water in the aqua cube.
The one on top.
Yes. And the second one is when you put water in the aqua.
Yes.
And
what was it? We don't even know what we're
So
talking
this
about.
question, just skip it. It's just saying how should be. There is no SC, it's S2C. S2C. Okay? And in such a way that S2F is 2 centimeter. S2F is 2 centimeter.
So we had already done it.
See? I don't know. Could we choose any?
We just take note that it change sheet. One of our one of our distance 0 from the ground.
I think it was 2 centimeters. Was it 2 centimeters? No.
Yes.
Je sais que c'était la
In our agency, we estimate
F prime is 2 centimeters, okay? Okay? S2C is this formula. We have done this calculation already. I don't want to spend time on that. We have done that. Just compute the position of C with F prime. We have done this calculation. The only thing that is fixed is S2 F prime, okay? S2 F prime for 2 centimeters.
And that's the same as S2.
The same as S2 F? No, F prime, sorry. F prime. Okay, you have another exercise too, exercise 1, with the aquascope. You need to work on that. I will give you the solution now during the break.
But in the first exercise, are we in the bubble?
Yeah, that's I wanted to tell you, I think that
Are we inside this? Like, is the
I think the water there. Okay? And
so it goes water and then air.
and air. Okay? That's for the exercise 1. You have water and it's curved toward the water. It's curved toward this way. Okay? So your diameter is like this. Here. And your eye is there. Okay? And the fish is there. In water. Okay? Let's start talk about the lens. So last time we did A, B, C, D situation and E of a magnifying glass. You had to draw all the situation. Hope you did it. And we skip the angle magnification, so today we're going to do that. And the eye. First of all, which situation corresponds to a magnifier, actually? You had 5 situations, you had 5 situations. Which one corresponds to a magnifying glass? Meaning you are la loupe. Where? Yes?
Of the places in the focus, the situation C,
Yes?
and your situation E.
Not E. So I want to show you clearly on the software. I have. You are the will say about it.
Okay, well, some, oh, it's a pain in the bone. I have a question.
I'm listening to you.
Yeah, for the last calculation, isn't it S2A1 instead of S2A? Because we have A1.
Oops, sorry, yes. Okay. Clear enough? Yeah, okay. So I can show you, by the way, what is happening when the radius is bigger. Radius of the lens is bigger. What does that do? The focal point is closer. Okay, focal distance is smaller. Let's come back to something. Object. Yeah. Okay. Let's take this one. So I'm interested in this part of the image, okay? I'm gonna change the position of the object to see what's happening to the image, okay? Here I have a virtual or real image. Real. Okay. So, change. Here, where is the image? It's a virtual image. No, it's not there. Look, where do they cross those?
They do not.
I'm gonna exaggerate.
Behind the object.
No, on the other side.
Where do they cross each other?
Oh yeah, on the other side.
Yeah. Okay. Those points will cross somewhere here. Okay. Here is the image. It's a virtual image. Okay. So what is happening to this image is I get closer to the focal point. What is happening? It is bigger. Eventually, if I'm at the focal point, where is B? Just like before,
Where is it? What is it?
B prime.
From it.
B prime, when I'm at the focal point, it's at infinity. How big is the image?
Well, it's infinite.
Yes. Okay. What about the apparent angle? Imagine you have an eye there. Okay. What is happening to the apparent angle? Yes.
You see when it's at the focal point.
Yeah. Actually, look at this angle. How does this angle changes as I change the position?
Smaller. It gets smaller. Now it gets bigger.
It is the same.
Oh.
Look, because this angle is the same. Image is bigger, but this angle is the same. This is something I wanted to show you. Okay. So from that, I want to define the angular magnification. Usually, we define the angular magnification for an optical system. For a lens, what is the magnification? Angular magnification. It's a characteristic of the lens. It does not depend on where I put my image. Right? It is the apparent angle with the lens over the angle when there is no lens. So what is this angle when you have no lens? That is the way you see it at point 2 maximum, 25 centimeters. Okay? Can you take this definition because you see some other ones. So no, we will take that one. Maybe I should write it down. Really want to do this properly. It's so important. So the angular magnification is very important for all the next class you will have, because you will see, I think, the microscope, the telescope, some optical instruments, and the most important characteristics for them is really to know the transverse magnification or the angular magnification, and be able to say which one is more important for those instruments. So really understand this definition, okay? Have a lens, just arrange it, okay? You have. Okay. It was the principal way. Okay. Later. Where is the email? I just find two ways, it's enough. Virtual. So, this one. Angular magnification. I think that's the notation you have in the Freeman. In the Pariso, we have this like grossissement.
I have a question.
Oh, yes.
If the angular magnification is 1, so the angle does not change. But
Let me explain when it's different from 1, okay?
But I have a question. I have
Yes, angular is 1, yes.
If it's 1 and the other one is more than 1, we see a smaller portion of the object but bigger.
Here we see an object bigger because angular magnification is more than 1.
That's not my question.
Does not
Actually, this will be like
The angular magnification is 1, but the is more than 1. What we see is still we just see a smaller portion of the object. But it's bigger. You see a fraction of it,
What is it all about?
okay. Yeah, it's
we are comparing to this situation. What is this angle actually? What is I should show you the image for this. That is the apparent angle for an eye at 25 centimeters. Okay. So you will see in some book that it's the version over 4, I think, because 4 is just because you compare to well, just take this definition for now, it's good enough. It's good enough. To do more than it. Okay. Let's go to in the Pariso, Think about it. You could compute actually this angle using F1. Okay? The focal distance. I want to show you.
J'y vais.
Yes. No.
Logiquement, t'es pignon.
Yeah.
La chaise de la table.
Oui, la chaise est
No. I'm gonna.
C'est pas clair. Non, mais il faut quand même le faire. Tu vas remonter. C'est la grosse molette.
No,
No, it's more. I don't want to do it.
La petite, c'est pour. La petite, c'est pour avoir d'accord. Voilà.
Wow. Amazing.
C'est sacrifice.
Je vais enlever ces trucs, là, ça m'énerve.
Ce qui est autour.
Oui, je sais plus, il y a un raccourci. Ça m'énerve.
C'est qu'on est devant.
J'ai perdu.
On va dire que c'est que
Show this to me.
Moi, je l'ai pas vu dans le
je suis grande.
Ah, One second, I'm sorry. Look at this image. See? So here we could compute actually theta prime with f prime, the focal distance. Yes.
Maybe the
Je peux pas faire les mains. Ok? C'est bon? Okay, so how do you compute the prime? It's just AB towards F prime. Okay? Okay? Therefore, if you use this and you take 25 centimeters as the contour proximal distance, you got, okay, theta prime equal to this. And as theta is AB over 25, finally, we could express the magnification, the angle magnification, in terms of the proximal distance and f prime. Okay?
So isn't it minus F1?
So equation
because it's SF.
yeah, I'm not sure about that.
I think it was written.
You could choose to have an orientation for the angle as well. You could do that. You could also talk about angular magnification without the angle. You don't have to be that perfect for angles. But if we define a rule, yes, you get that. But no, F prime is negative. No, F prime is positive for the lens. D? That is 25 centimeters. Okay? Which is why actually, finally, you get, okay? You are doing AB over F prime over AB over 25. Right? So you have D25. So if you choose this one in centimeters, 1/25 is 1/4. Some other unit. So in the system international, in international system, you get the magnification is the versions over 4. Could be useful. Okay? In SI unit. In the SI unit, you get is it version 100?
You see
That is for
Written.
lens.
On the board.
Just for lens.
on the board?
Can you see it?
And
Barely.
Exactly.
okay, we got 10 minutes left to do the next part. So we are not doing it, but we are starting to talk about myopia. We are late, I'm sorry about that. I don't feel like going so fast on this activity. And the password. We have talked about aberration last time. Chromatic, spherical, stigmatism, and that. So let's talk about the eye. So what is myopia? Myopia is an eye defect. I have prepared a presentation about it. Nothing important, just the basic here about the eye. The eye, you know, in an eye you have actually different diopters. It's not just a lens, it's not a diopter, it's a little bit more complicated than that. Okay? The light enters through the cornea, passes to the retina. Okay? So I will give that to you if you want. Learn the basic about an eye. Some visual defects as we are doing today is the farsightedness and the nearsightedness. So what does that mean? When it's nearsightedness, which is myopia, which is what we are doing now, your image is constructed in front of the retina. Okay? Farsighted is on the other side of the retina. The image is behind the retina. So your eye is seeing what's there. So that means that the image is not clear here. It's blurry because we got multiple points for one image. So the image is not clear. Okay? So we are in this case. So what should we do to repair this problem? Okay. The image given by your eye is in front of the retina. So what should you do?
We have to increase the focal distance.
Can we like remove?
We can. The eye is the eye.
Yeah,
We
but
add
then-
some glass
yeah,
and photo.
Isn't there surgery to like make it thinner?
Yeah, but we don't do surgery. Here we just use glasses. So what should you put in front of your eye to repair this problem? Somebody did it last time. I saw somebody playing with divergent lenses and adding a divergent lens to a convergent one. What does it do?
Negates both?
It compensates.
Yeah.
So they have to be the same reservoir.
Yes. So here you don't want it to be the same.
No.
You just want to have your image in the retina. Okay. So, question. Illustrate the principle of the correction of a myopy nearsighted eye using the laser and lenses. So we don't do that. Do the construction of it. Okay, for question 1, just do the construction. No laser, just do it. To find the image for the eye, you just choose an image which is in front of the retina and try to find the image using another lens in front of it, a divergent one. Should I draw the program? I will send that to you, okay?
I don't understand that. That's TR equals what equal we should TR and
Just take something
to exercise here, so it's lower. So it's here. You have CR equals
Yeah, we do question 1. Just question 1 for now. Do the construction of it. The drawing. And try to pay attention to virtual and real objects. Okay? Distinguish the two. You are not leaving this room unless you have done this construction.
True.
The one I just said.
But you don't need the strong
If you need to draw a divergent lens, draw it that way. Well, it is not really asked in the French. But we should do that. A divergent lens is exactly as a convergent lens, except that focal points are
Okay. So,
can I see? I'm just drawing this for you to know how to do a divergent lens. But you need to draw the situation of I and yes. Yes. Okay, I will start back on you. Just understand that the retina is there and the image is in front.
Me, Sarah? Or someone else, Sarah?
No, Sarah here.
If there is no lens,
Draw
given by
this, I think. Doesn't mean I'm doing
in
it.
this
But
example,
We have
we
to draw
could
something.
I
choose
think I'm
to
lost track of what
simulate
we're
the
doing.
eye with a lens. Instead of saying the eye is a diopter, you could say it's a lens. Okay? Maybe that's easier.
But it's false.
Your eye is just a lens. That is giving an image in front of the retina because you have myopia, right?
Go back home and cry. Just have a good cry session and then do work. Yes, please join me. We'll fill up a couple of tears and then we'll swim.
We can drink it. Why not? It's forget about it.
So A2, B2 is the image when there is no divergent lens. So try to find A2, B2 prime. Let's call it A2, B2 prime. Whenever you have an image, when you have a divergent lens. You need to add actually AB. Okay? You could add AB, the object somewhere. And then A1, B1. Right? From A to B. Once you got AB, try to find A1, B1, image given by the divergent lens, in such a way that your image gets the retina, the final image. Okay? It's an exercise, just an exercise.
You did some Franklin design thing.
Is it clear? Is the question clear or not?
No.
No? Yes.
If it was someone long size, would be convergent.
If
It was someone long size, it's a short size.
a nonsense? I don't understand.
Long-sighted.
It was
Ah.
long-sighted instead of short-sighted.
Okay, I don't use long. I use near-sighted or far-sighted. So this is near-sighted. I think the English one are saying in England you say long,
Long-sighted.
and in the US you say near-sighted and far-sighted. So near-sighted is when your image is in front. This is near.
Yeah, and
So
long-sighted.
this is.
So with the instead of having a
Valley girl.
Voilà.
So when it's long-sighted, it's but we are
Yes.
Well, I just wanted you to follow. Okay, maybe the exercise. Okay. I just wanted you to draw an image. Okay. An object. And then add a divergent lens so that the image is here. So if you go down like from B to the middle, and then you go like, where is your galaxy? Okay, you have it here. You will have to do that here. Maybe you should practice those first. That correspond to two lens association. But this one. Okay, maybe we skip that for today. It's too complicated. The second question, but everybody got that, right? We need to add a divergent lens. Diverge the way in such a way that we got it in the resonance. You have something to find out. It's 5:15. You have class?
No, it's 6:05.
There is something.
Oh, yeah.
Not
But
important.
I have a meeting with the Kevin. I need to go back home for it.
When?
I think,
Can we finish question 2?
Oh,
Can I do that question 2?
But we have 10 minutes left.
10 minutes left. Good. Question 2.
Nice. Very sexy.
What does it mean? Repairing sites at infinity.
well, for an image at the point 2 remote would be focus on the resonance.
I mean that the image that you see in such a way that, well, so the punctum, the PR is 40 centimeters.
What is oh, okay.
It's explained
It's a
again.
punctum momentum, so you mean that an object at 40 centimeters appears from the red.
Yes.
Yes, I get conflicting answers. Yeah, no, like it's a teacher.
Sorry.
Okay, so you need to draw the situation, right? In this problem, the eye is a lens, right?
Okay.
I mean everything.
Okay, the whole thing.
The whole thing. So we say that the punctum momentum I think, right, that you should have 40 centimeters between your object and the eye, and it is saying that you have the correcting lens at 1 centimeter. We don't have to draw it because 1 centimeter is too close to the. You have to compute the focal length of the correcting lens at 1 centimeter of the eye restoring percent infinity. So how to compute that? Which formula should you use?
This is way.
No, this is not diopter. The last formula. The last formula. Just two lenses. Okay, one, two, four,
The window is like what? I think my window everywhere.
Like a whole
I think
Yes, it's from the.
so. In this case, okay, AB has the image A1B1, 2,
Yes.
6, and then for the other lens, okay? Let's use those notation. Object, image, for the first one. Object, image, for the second one.
Nice.
So what is the difference? Do you remember? What is the lens formula?
Yes, but how is the lens?
Minus 1 minus
Pas d'or.
equals 1.
I'm not writing with those notation, but you have to.
Yes,
Okay? This is a unique formula for a length. Difference between a convergent and divergent one is that f prime positive for a convergent length, f prime negative for a divergent length. But that's the same for me. Okay, go for it. You want to see the image like this before that finish, right? There is no calculation to do. If you want to see your image at infinity, where should be the object for the divergent length? On the focal point? Yes. So where should be the focal point of the divergent length? Where should be the focal point of the divergent length?
On L2? L2? I don't know.
Yes, yes.
But why? I said it, but I don't know why. I just don't know.
Yeah, right?
Is AB at infinity?
No. But the image is at infinity because it's easier to see image at infinity.
But what is AB? What is AB? Where is it?
A, that's the object.
Okay.
If I put that at the focal point of this, I will see an image at infinity. So I think that
Can you draw the way?
the focal point of the lens.
Nice.
If we calculate f prime, which is the focal, if we have f prime with that formula, is it giving us the focal length of L1 or L2? L1, or the focal length of both together? No, L1. No, it's not together. L1, you should always, do one at once. One formula at once for one matrix. If there is no formula yes. For L1. For L1. Yes. So the way to say it, okay, if your A2, B2 is at infinity. You should have OA1 equal 1 over F prime.
No.
Okay, which gives you A. This one is F1. You use the formula.
Oh.
Moi, j'ai 2 sur 29. Je pense que les gens sont pareils.
So now that you know what is a divergence and what is a convergent one, you should be able to start to do all those constructions, right? Yes. So the way when you do the construction, just to help you, when you have a divergent class, that is exactly the same thing, except that. Can I avoid that?
Well, probably. I might have stolen it. Do you have Imperial? Yes, I am Imperial. I don't want it. It's not that much.